Hello my dear students, welcome to my channel Dey Sir's Chemistry Coaching. Please do subscribe my channel so that if you are willing to give any medical or engineering entrance exam, I will upload all the expected questions, answers and with explanation. So please like, share and subscribe my channel, okay, so that my new videos will reach to you. So let's start. Now see the question. This is very important question for this year. One complex is given, any complex. Find the hybridization, magnetic nature and spin nature of the complex ion. It carries 3 marks. So see the answer, how to do. Atomic number is given 27. Actually this is a concept on valence bond theory of hybridization. Valence bond theory of hybridization. Directly you can write the hybridization, but it is very difficult to find the magnetic nature. So see the answer. Just at first write the electronic configuration of cobalt. 27 atomic number. So it is argon 18, 4s3d, d orbital contains 2 electrons and d orbital contains the rest 18 to 20, 27. Remember it, this is the valence shell, this is the valence shell, outermost shell. Now second part is that find the oxidation state of cobalt. Oxidation number of cobalt. COF6 3 negative. This is ion. The rule to find the oxidation number is just add the oxidation number of all equal to the charge. So say cobalt is x plus 6 into minus 1 equals to minus 3, therefore x equals to plus 3. So during the formation of this complex, cobalt releases 3 electrons from its valence shell. So the electronic configuration of cobalt plus 3 is argon 18, 4s0, because this is the valence shell. We need to remove 3 electrons, so 3d6. Now one technique, write it, one technique is there. What is the technique? Listen now the technique. If the coordination number of central metal is 6, then remember it, either, this is a technique, don't write in the answer, this is a technique for you, either D2sp3 hybridization or sp3d2. So the question is that which hybridization occurs here? That's the main thing. If the ligand is a weak field ligand, then the probability is this. If the ligand is a strong field ligand, you know that NCS negative, cyanide, ammonia, ethylene diamine, carbon monoxide, these are strong field ligand. So if the strong field ligand is there, probability of this. If weak field ligands are there, all the halogens are weak field ligand, oxalate ion weak field ligand, probability is this. So now the next step, see it, okay. listen the step next. Just draw 3D orbital. Continue answer, okay? Draw 3D orbitals. You know that D orbital has 5 rooms. D6, 3, D6. So according to Hund's rule, 1, 1, 1, 1, 1, and then this. After 3D orbital, 4s. Now, as you know that if there are 6 coordination numbers, either D2sp3 or sp3d2, so we need p orbital also. So this is the 4p orbital. Remember it, there is p orbital in every complex metal ion, but it is vacant, so we did not write it. Now as it is required, so write it. Next step, see the ligand. If the ligand is a weak field ligand, it cannot vacate the d orbital, because the valence bond theory of hybridization rule is that the hybrid orbitals, these are the hybrid orbitals which are taking part in bond formation, should completely vacant. Which are taking part in bond formation should completely vacant. That's why fluoride, being weak field ligand, cannot vacate the 3D orbital. So 4D orbital is used here, that is 4D orbital is used here for hybridization. So we need 6 hybrid orbitals, 1, 2, 3, 4, 5, 6. So we need only 2 d orbitals, only 2 out of the 5 d orbitals, we need only 2 d orbitals. Now you know that each ligand donates 2 electrons to form a bond. Each ligand donates 2 electrons to form a coordinate bond. So there are altogether 6 ligands. So 6 into 2, that is 12 electrons we get from the ligands. That is fill up here. So direct configuration of this CO F6 3 negative. Just draw again same way. This 1, 2, this. Now 3D, 4s, 4p, 4d. So just 1, 2, 3, 4, 5, 6. So 6 sets of sp3d2, 6 sets of sp3d2 orbitals. As I have told you that each ligand donates 6 electrons. So there are 12 ligands, 6 into 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now listen the answer. So which hybridization takes place here? sp3d2. So sp3d2 hybridization takes place here, okay? sp3d2. What is the magnetic nature? Magnetic nature means whether it is paramagnetic or diamagnetic. Listen, as there are unpaired electrons, so it is paramagnetic. If there is one unpaired, that's also paramagnetic, so it is paramagnetic in nature. Spin nature, d orbital. If the d orbital at the end, then high spin complex. If the d orbital is before sp3, that is low spin, so it is high spin complex. Now I will erase it. So listen. So the final answer, this is the final answer is, so which hybridization takes place here? So the hybridization is actually hybridization at central atom, okay? sp3d2. Next, magnetic nature, remember it, magnetic nature means whether it is paramagnetic or diamagnetic. I have already told you there are 4 unpaired electrons, so it is paramagnetic. Paramagnetic due to the presence of unpaired electrons. And number 3rd one, spin nature. Don't write, listen. If D orbital is before sp3, that is low spin. Don't write, only listen, low spin. If d orbital at the end, that is high spin complex, okay? So it has high spin complex. So high spin, it is high spin complex or outer orbital complex. So these are the answers, okay? These are the answers. What is the shape? If the coordination number is 6, remember it, always octahedral shape. It is not asked in the question, still write down, it has octahedral shape. It has octahedral shape, okay? So I think you understand it. Listen the question, okay? Write Freundlich adsorption equation. Second question, during chemisorption, why with increase in temperature the amount of adsorption increases at first? So listen the first question. Actually, Freundlich isotherm equation is related to the amount of adsorption and pressure. The answer is, this is the extent of adsorption. Extent of adsorption, that is x by m. No need to write, only listen. X is the mass of adsorbate, m is the mass of adsorbent. If ammonia gas is passed over a piece of charcoal, then ammonia gas molecules are adsorbed on the charcoal. So here charcoal is adsorbent, say the mass of adsorbent, and ammonia is adsorbate. According to Freundlich, this is extent, okay? According to Freundlich isotherm equation, the extent, it is T, okay? Extent of adsorption is directly proportional to the 1 upon nth power of pressure. 1 upon nth power of pressure. N is an integer that is in between 0 to 1. 0 to 1. Now this is the second question, where n is the integer. Remember it, it ranges from 0 to 1. During chemisorption, why with increase in temperature the amount of adsorption increases at first? Actually, if you draw the structure, this is called adsorption isobar. What is adsorption isobar? It is the graph between the amount or extent of adsorption and temperature at constant pressure. If you draw for physical adsorption, if you draw the graph for physisorption, the between amount of adsorption or extent of adsorption and temperature at constant pressure, then the graph is called adsorption isobar. In case of physical adsorption or physisorption, the amount of adsorption decreases with increase in temperature. If you increase the temperature, the amount of adsorption decreases. Can you tell me why? Because during physical adsorption, the attraction forces between the adsorbate and adsorbent is very weak, like van der Waals attraction force. So if temperature increases, the adsorbate molecules go far. That's why the amount of adsorption during physical adsorption decreases with increase in temperature. But if you draw the graph for chemisorption, it has been seen that with increase in temperature at first, the amount of adsorption increases and then start to decrease. Now the question is here, why during chemisorption the amount of adsorption increases at first then decrease? Listen, as temperature increases, the temperature provides the activation energy to the reactants so that the adsorption increases. So what is the answer here? See the answer from here, okay? Now, so the answer is during chemisorption, the increased temperature provides, during chemisorption, the increase of temperature at first provides the activation energy for which the rate of adsorption increases. So the answer is during, this is the actual answer, okay, this is the actual answer, during chemisorption with increase in temperature, the temperature provides the activation energy so that the amount of adsorption increases. This is the answer, okay? See the question, okay? The first question is, what is Zeta potential? Second question is, this is a colloidal solution. You know that colloidal solutions are called salts. Separately, if we add magnesium chloride or potassium sulfate or potassium ferrocyanide, which of the compound is the most effective to coagulate this colloidal solution? Both are very important, okay? Now, at first see the answer B, then I will discuss this, okay? Actually, we have to draw it. This is according to Hardy-Schultz rule. Listen, what is Hardy-Schultz rule? Before that, what is coagulation? Say, consider a beaker containing colloidal solution. It may be positively charged salt or negatively charged, whatever it is. Add excess of electrolyte, say NaCl, KCl, any salt. Excess of electrolyte, then you see after some times a precipitation takes place at the bottom of the test tube. This phenomena is called coagulation or flocculation. So what is coagulation? It may also come, okay. Coagulation is a process when excess of electrolyte is added to the colloidal solution. The colloidal particles undergo precipitation. This is called coagulation or flocculation. According to Hardy-Schultz rule, coagulation of a colloidal solution depends on two factors. One, if this colloidal solution possesses positive charge, then the oppositely charged ion of the electrolyte, that is the negative ion of the electrolyte, is responsible for coagulation. Once again, if the colloidal solution possesses negative charge, then the positive ion of the electrolyte is responsible for coagulation. Just opposite ion. Second point of Hardy-Schultz rule, greater the charge on active ion, that is ions responsible for coagulation, more will be the amount of precipitation, or you can say more will be the coagulating power. So listen, directly it is mentioned that it has positively charged colloidal solution. So negative ion is responsible for coagulation or precipitation of colloidal particles. Now, if you dissociate, no need to show dissociation, okay. If you dissociate negative ion, chlorine possesses -1 charge, sulfate possesses -2 charge, and this possesses -4 charge. So you see that according to Hardy-Schultz rule, greater the charge on active ion, that is ions responsible for coagulation, more will be the coagulating power. So this is the answer, highest. So the answer is the negatively charged ion is responsible of coagulation, that is precipitation. Greater the charge on the ion, more will be the coagulating power. Greater the charge on the ions, okay, greater the charge on the ions, that is causing coagulation, more will be the coagulating power. So it has the highest coagulating power. So the order is not asked, okay, the order is not asked. So the order, the decreasing order of coagulating power is 3, greater than 2, greater than 1. That's the answer. It is not asked. Still, I have seen sometimes this type of question, okay. So I think you understand one extra thing. If the colloidal solution possesses negative charge, then the positively charged ions are responsible for coagulation. Remember it, just opposite. Greater the charge, more will be the coagulating power. So see the answer of the first one, okay. What is Zeta potential? Actually, you know that colloidal particles possess same charge, either positive or negative. Now listen the Zeta potential, okay? Concept behind the Zeta potential. 4 years back I have seen the question, okay? And last 3 years I have not seen this question. So listen, it is the potential difference between the dispersion medium and the stationary layer of the fluid attached to the dispersed particles. Understand it. If you consider a positively charged colloid, say if you consider a positively charged sol or colloids, say ferric hydroxide, how it becomes positively charged? During the preparation it carries positive charge actually. If you consider the center of ferric hydroxide, one particle, surrounding it there is a layer, fixed layer of positive charge. There is a fixed layer of positive charge. This is called fixed layer. Just outside the fixed layer, the negative charge particles are assembled. So this is the stationary layer, this is the fixed layer, this is the fixed layer, and this is the stationary layer. That is the layer of negative charge ions. In between the fixed layer and the stationary layer, there is one charge difference, that is difference in potential. That difference of potential is called Zeta potential. So if you can remember it, then write, important. But if you can't remember it, directly write. It is a potential difference between the stationary layer and the fixed layer. It is a potential difference between the stationary layer and fixed layer in a colloidal solution. It is a potential difference between the stationary layer and the fixed layer in a colloidal solution. That's right, okay? So I think you understand it. Follow the next question. So see the questions, okay? This is very important question. First is that transition metal ions are given. Atomic numbers are also given. Which is the most stable? Which is the most paramagnetic? Which form or forms colorless salt? Which is the strongest oxidizing agent? That's the question. Now, if this type of question will arise, always write the electronic configuration of the parent metal atom and then the corresponding ion which are given. Which is the most stable, which is the most paramagnetic, and this. So try to write the electronic configuration of this, okay? So see the answer. Mn25, argon 18, so 4s2 3d5. So listen, this is the valence shell. So Mn3 positive means 3 electrons are removed. Whenever electrons are removed from an element, electrons at first will remove from the valence shell, then if required inner shell. So argon is there 18, so it is 4s0 3d5. So the d orbital contains 5 electrons here. Now actually we have to remove 3 electrons, so the d orbital contains here 4. You know that there are 5 d orbitals. Put the 4 electrons, 1, 2, 3, 4. So total number of unpaired electron in Mn3 positive is 4. So total number of unpaired electrons in Mn3 positive is 4. 1, 2, 3, 4. Now listen. So in this way, if we write the electronic configuration, of all the ions, if you write the electronic configuration of all the ions in this way, so it becomes like this. So chromium 3 positive, chromium has atomic number 24, so argon 18, 4s1, this is exceptional, copper and chromium has 1 electron in 4s, so 3d5. This is the valence shell. So chromium 3 positive contains argon 4s0 3d 3. Similarly, for titanium 22, argon 18, 4s1 3d 3, 18 and 1 19 and 3. So titanium 4 positive equals to all the 4 electrons are removed, so you get only argon, that is it has 18 electrons. 18, okay, 18. Now another is zinc. Zinc has atomic number 30, so argon 18, 4s2 3d 10. So zinc has Zn2 positive has argon 18, 4s0 3d 10. Now listen, manganese tripositive has electronic configuration this. D orbital has 4 electrons. Chromium tripositive, D orbital 3. Titanium 4 positive, D orbital there is no electron, only argon is there, and here also this. Now the question, you know that greater the number of electrons, more will be the paramagnetic nature. So Mn3 positive is the most paramagnetic as it has 4 unpaired electron in d orbital, that is 3d orbital. 4 unpaired electrons, I have already drawn it. Okay. Now the third question I have given, which form or forms colorless compound? Remember it. If any transition metal ions has only paired electrons, that is, if there is no unpaired electrons, that salt is colorless or white. In chemistry, white is considered as colorless. So remember it. If any ion is diamagnetic in nature, that is, if all the electrons are paired, it is the salt is colorless or white. If any ion, transition metal ion, contains unpaired electrons, the compound is colored. So the third answer is titanium 4 positive and zinc 2 positive. In both of them, all the electrons are paired. So both form colorless compounds, while for them the compounds are colored because they are paramagnetic in nature. So Ti 4 positive and Zn 2 positive form colorless or white compounds as they are paramagnetic in nature. They are diamagnetic in nature. They are diamagnetic in nature. Diamagnetic means all the electrons are paired. Now the fourth question I have given, which is the strongest oxidizing agent. Listen the technique. You know that if this compound undergoes oxidation, then it releases electron. So you see that this compound undergoes oxidation because it releases electron. Someone has to carry the electron. Here I am taking the electron, so I am acted as oxidizing agent because I am helping to undergo oxidation of this compound, that is, I am acting as oxidizing agent. Most of the transition metal ions act as oxidizing agent to become stable configuration, So listen it. That's a very important question. So remember it. Oxidation means loss of electron. Oxidizing agent gains electron. So the fourth question answer is listen now, if we consider Mn 3 positive, okay, it has configuration 3d4. If it can gain electron, so if Mn 3 positive can gain 1 electron, so it becomes Mn 2 positive. That is, it has configuration 3d4 and after gaining electron it has formed 3d5. So you know that if d orbital contains 5 electrons, it is called half filled. So it is, that's why, and half filled orbital is very stable. That's why Mn3 positive is the strongest oxidizing agent, because it has a tendency to gain electron to become stable configuration. So Mn3 positive is the strongest oxidizing agent. Okay, it is the strongest oxidizing agent. Now listen the first answer. I have given the first question, which is the most stable, which is the most stable. Okay, now this is the most stable. Why? Listen now. So write the answer. Cr3 positive is the most stable, as if you draw according to crystal field theory, if you draw its structure, d orbital, 3d orbital contains 3 electrons, 1, 2, 3. You know that according to spectrochemical term, the lower energy level is called T2G and higher energy level is called Eg. T2G orbital contains 3 d orbitals, dxy, dyz and dzx, and Eg contains 2 dx square, y square and dz square. If you fill up the 3 electrons, you know that according to Hund's rule, electrons are filling up from lower energy to higher. So 1, 1, 1. So it is half filled. That's why it is the most stable, because the T2G orbital contains 3 electrons, that is half filled. So the explanation is as T2G contains half filled stable 3 electrons. So that's the answer. That is the answer. Okay. So I think you understand it clear. So thank you for being with me. So please subscribe my channel so that you can get more and more questions on your coming entrance exams. Okay. So thank you.